Welcome to Bungalows for Bachelors. Today we are going to get learning about electrical work. This can be confusing, but today you're going to understand how things work and it's going to all make total sense for you. So, generally speaking, what are the electrical trades? Well, what does electrical mean? Well, generally speaking, it's the distribution of the wiring, lights, and receptacles and anything else that you're going to wire into your house with wires that the electricians are going to install. That's basically what the electrical trade includes. And the purpose of the electrical trade is to get a few different types of things in, right? So the main thing that most people think about is the accessible power, right? So you need to be able to plug in your phone charger, plug in your USBs, plug in your laptops, plug in whatever you want, right? All over your house, your vacuum, all that stuff, right? So you need accessible power to do that. And your dryers, bigger equipment takes more power, right? So you're going to have different kinds of plugs. But that's generally it. You're going to have your 110-volt plugs, which is the standard outlets you're going to see all over the house. And then the 4-prong outlets you'll see for like a dryer plug or something like that are going to be 220 volt. So that's one of the main purposes is to spread the power out through the house so that you have access to it. Another purpose is going to be the lighting. You want to, of course, make sure that you can turn lights on in your house and control them with switches. So that's another very important thing electricians take care of. And then there's communication lines. So sometimes people want, it's not as common nowadays because Wi-Fi is pretty good, pretty powerful. But occasionally people still want wired internet throughout their house. So they're going to have the Cat 5 cable or something ran throughout their walls to go to different rooms or maybe just to an office or something like that. But basically, your internet lines are going to be pre-wired and there's going to be plugs for them in your walls. So you can plug in and have hardwired internet to your computer, which is generally a little bit faster. And phone lines nowadays being in the walls is kind of obsolete. So same thing with cable TV. It can be ran, but it is less common. And then signal. So signal wires are things like the garage door push button openers. Those wires are just small little low voltage wires that are ran from the push buttons up to the motor, the controller for the garage door. And that wiring is done by the electrician. And then there's things like speakers. If you have a big media center, big TV thing, and you want speakers ran up in your ceiling or your walls or whatever, they'll run wires for that. And then, of course, there's hardwired in security, which is still done occasionally, but nowadays a lot of security systems are wireless. So these are things that electricians would install in your walls. Now, to understand the electrical system in your house, it's best to know generally where is this stuff coming from and where is it going. So electricity is generated in many different ways, but the basic premise is our houses run here in America on 120 volt AC power. So the 110, 120, the basic premise, 60 hertz, right? So 60 hertz means 60 cycles per second. And a cycle means, I'm not going to go into too much detail on AC voltage, but the basic premise is 60 times a second, a shaft is going to rotate somewhere. And that shaft spinning is going to be spinning a magnetic field that is going to induce current into a coil of wire. And when it does that, the coil is energized, and that's where the electricity is generated. And that electricity, wherever that coil of wire goes, wherever that circuit is going to run electricity through that whole line. So what happens is there's a main line that starts at a substation or a plant or something like that, where the power is being generated. That circuit is being driven by some motor somehow. And that power is distributed through these, power lines that go long distances, right? And things like that. So those power lines are all part of the same circuit, but that is generally how that works. And that goes all the way to let's say there's only one, you take it to your transformer that's by your house. So the power source all the way to the transformer is going to have one big circuit of wire, one big loop for electricity to flow. And at the transformer, it's going to have inside a transformer, there's going to be one coil of wire next to another coil of wire. It's a separate circuit. But what's going to happen is that's going to step the voltage down in using electrical magic, right? It's going to step that voltage down to a level that is appropriate for your house, right? So long distances, you want higher voltages because it's more efficient to transfer the power. And when you're closer to your house, you don't want super high voltages because you don't want to blow things up and kill people, right? So you step down the voltage and at the transformer, and then that circuitry goes down to your meter, right? Because the power companies need to know how much you're going to use so they can charge you for it. So the first thing it's going to run through is your meter, and then it's going to go into your main panel. And if you have sub panels in your house, they're just like the main panel, with a few exceptions. But it's generally just, there are the ways of distributing these circuits so that you can get electricity conveniently to different places. So, of course, and then there's all the way down to the house circuits, which is where the loads are applied. You're going to plug in your vacuum, or you're going to plug in your dryer, things like that. So, now, generally inside a house, things are distributed with power cables that look like the photo shown. Generally, they're going to be using, a 12-2 cable or a 14-2 cable, depending on the type of circuit, right? And I'm not going to go crazy into loads and types and gauges and things like that. But the basic premise is there's a few different gauges, a few different sizes of copper wire. Sizes referring to the diameter of the wire. And the way these wires are delineated is the first number is the gauge of the wire itself, right? So each of those wires in that picture, let's say it was a 10-2 wire, 10-2, Romex or 10-2 sheathed cable, whatever you want to call it, non-brand name. All three wires are 10 gauge, and two of the wires are designed to be conducting wires. So the center wire, that's the bare copper one, is the ground wire. That's just the safety wire, right? You're going to connect that wire to all metal things. It's designed to be a safety mechanism. So all metal things are connected to each other in the system in case of a ground fault. And the other two wires are going to be you can think of it like the outgoing and the incoming, right? So your electricity is going to be on the red, or sorry, the black wire would be, the hot wire, and that's the theoretically the energized, the voltage applied side of the circuit, and the white is the neutral wire, which is where the electricity can return back to the panel. So because for electricity to work, it has to flow in a loop, right? So you got to create a loop. So that's what the wires. That's why these sheathed cable packages come like this, is so that you can basically have run a single run of cable, and you get a loop if you've already got a loop inside your cable because you got wires going both directions inside. So it's convenient. So the second number, like I said, is the number of conductors. So occasionally you'll get a 12-3 or whatever. You can have more than just two conducting wires in your package depending on what you're running. And like a dryer, for example, that's got 4 prongs is going to have a 10-3 or some kind of wire like that has three conductors in it. There's going to be 2 hots and 1 neutral. And the reason there's 2 hots is because you're effectively adding up the 2 hots to get the 220 volts instead of the 110 volts or whatever it is. So that's the basic premise of the cables. Now, inside the main panel or surface panel, you're going to have all kinds of things. So the first thing to notice is that it's a big metal box, and that metal box is going to be grounded, of course, so it's safe as with all other metal parts in the system. All right, so inside the box, you're going to have, generally, if this is the main panel, you're going to have 2 hot bars where this panel is missing the actual wires from the power supply. You would see 3, or you would see, 1, 2, 3. Yeah, you would see 3 and then a 4th, depending on where your ground thing is going on. You would essentially see 3 big black, like number 6 gauge or number 4 gauge wires from the power source that come in the box and plug into these big lugs right here. So here's 1 lug, here's 2 lug, here's 3 lug. All right, and there's going to be another one somewhere that's grounding the box, and that ground cable is going to run down into like a piece of rebar that's connected to the foundation if it's a concrete foundation or something like that. There's going to be a grounding rod somewhere. It's going to connect to that and come into here and ground to the panel. So that's what the basic premise of this whole electricity thing, right, is you're trying to create loops, trying to create circuits, and you do that by connecting one piece of metal to another piece of metal. So when you bring in, let's say, one hot big wire and you screw it down with this lug is connected to a big bar strip, and that strip is running down here. And there's another hot right next to it, and basically these usually have like little forks that stick off and they kind of interweave, which allows you to install different types of breakers and get different combined voltages, right? So you can either have a single breaker that sits on one of these and one of these, doesn't matter which one, or you have a breaker that kind of combines the two, and that's where you get the double voltage, the 240 volt, 30 amp circuit kind of stuff. So that's the basic premise. There's these long bars, and these breakers just kind of snap into place and connect them, and then you connect your wires to the breakers, and the wires run out to your outlets and your lights and things like that, so that everything's protected by the breakers. And occasionally you'll also see a main breaker or a main supply breaker that's designed to shut off the whole thing, or a main shut-off switch is kind of nice to have. Otherwise, if you don't have that, then the only way to de-energize this whole system is to unplug your meter, which is a pain because then you got to contact the utility company if you want to do it correctly. And then over here on like the right side of this lug is the like a neutral bar. So the neutral bar is where all of the white wires are going to come back, and that's where all the electricity theoretically is coming back into the box to return back out to the source of power, right? So that you're creating your loop there. Now, one of the other special things in the main service panel is going to be bonding. So the neutral bar is going to be connected, and bonded is what it's called. It's going to be connected to the grounding bar somehow. All right, you're going to take a jumper and connect from one over to the other. And what that's going to do is if there's a ground fault anywhere in your system, like you have a hot wire in your dryer and it accidentally comes disconnected and touches the metal that is the dryer box or whatever it's made out of, then that dryer box has been grounded because of how things are made safely, right? So what's going to happen is that bond here is going to allow the circuit to be completed, and it's going to allow the electricity to flow from the hot. Oh, the hot touched the box of the dryer. Oh, that shorted the circuit. That closed the circuit. So now the power is going to run through your dryer box back into the ground, through the ground, all the ground wires back into this panel, and this jumper is going to say, okay, I'm connecting from the ground where that fault was, back to my neutral, so I'm finishing the loop, right? And you only want to do that here in the main panel so that it's a safety thing, and there's more you can learn about that later, but that's the basic thing that's special about the main service panel. But that's that. So if you'd like to learn more, and there is way more to learn because I just summarized things, you ought to watch the YouTube Spec House series episodes 38, 97, 100, 102, 112, and 132 by the Essential Craftsman to see how he incorporates electrical work into his spec house. You ought to watch the YouTube video Why Do We Bond the Service Panel and Not a Subpanel by Electrician U. And then go ahead and just watch everything else by Electrician U because they are fantastic, super high quality content, and you can learn a lot about electrical work. That said, thank you for watching, and I'll see you on the next one.